Good morning, Professor Madya Dr. Hazlina Ahmad Zakari and fellow friends. And today, we are going to present our industrial enzyme case study, which is Farm Fresh Malaysia. Our topic is lactate application in lactose-free milk production. We choose this case because Farm Fresh produce lactose-free milk for consumers who are difficulty digesting lactose. In this presentation, we will explain the industrial problem, how lactase enzyme is applied, and the enzyme mechanism, industrial value, limitations, and purpose of improvement. For the first slide, I will explain the industrial problem and why lactase is needed. First, under lactose intolerance in Malaysia, lactose intolerance affect about 90 to 95% of the Malaysian population. The highest prevalence is among Malays, which is 72%, followed by the Chinese 59% and Indian 42%. Second, under consumer needed, lactose intolerance individual cannot digest lactose properly. Lactose is a disaccharide found in the milk. When lactose is not digested well, consumer may experience symptoms such as bloating, abdominal discomfort, and diarrhea. Third, this creates an industrial challenge. The dairy industry must produce milk that is digestible for lactose intolerant consumer. Farm Fresh Malaysia address this issue through enzymatic hydrolysis using lactase. So, lactase is needed because it helps to convert the regular milk into lactose-free milk, making it easier to digest and suitable for lactose intolerant consumer. Next, I will explain how lactase is applied in the production process. Next, this slide explains how lactose is used in lactose-free milk production. The enzyme issues lactase, also known as beta-galactosidase, with the enzyme code EC32123. This enzyme can be obtained from microbial source such as Cluviromyces lactis. For the applications method, lactase can be added using an inline dosing system into a temperature-controlled stirring reactor. This helps ensure the enzyme is evenly mixed with the milk under suitable process condition. The process starts with number 1, milk is pasteurized to reduce microbial contaminations. 2, the milk is cooled to 37 degrees Celsius, which is suitable for lactase activity. Third, lactase enzyme is added into the milk. And fourth, lactose is hydrolyzed for about 3.5 hours. Number 5, the enzyme is heat inactivated at 85 degrees Celsius for 30 seconds to stop enzyme activity and prevent unwanted browning. Finally, milk is packaged, and the hydrolyzed reactions is lactose plus water produce D-glucose and D-galactose. This reaction reduce the lactose content and make the milks easier to digest for lactose intolerant consumer. Show the overall flow chart of the lactose applications in lactose-free milk production. Number 1, the process start with raw milk as the main material. Number 2, the milk undergo pasteurization. Pasteurization is a process to reduce microbial contaminations and to improve product safety. Number 3, the milk is cooled to 37 degrees Celsius, which is suitable temperature for lactase activity. And number 4 is lactase enzyme is added into the milk. 5, lactose hydrolysis. Lactose hydrolysis occur where lactase break down lactose into the simpler sugar. And the 6 is the enzyme is heat inactivated. This is to stop the enzyme reaction. And the number 7, the milk is packaged under hygiene condition. And last, the final product is lactose-free milk. At the bottom of the slide, the reaction shows that lactose react with water to produce glucose and galactose. This reaction is important because glucose and galactose are easier to digest compared to lactose. Therefore, lactase help convert regular milk into lactose-free milk that is more suitable for lactose intolerant consumer.
Now I will explain how the lactase enzyme works from the technical perspective. Fundamentally, lactase acts as a catalyst for hydrolysis of the beta-1,4-glycosidic bond in lactose. This process follows a double displacement mechanism where lactose binds to the active site of the enzyme. Next, the process of glycosylation forms a covalent glycosyl enzyme intermediate. This is followed by deglycosylation, where water releases lactose and the enzyme is regenerated. To ensure the efficiency of this process, the operating condition must be maintained at the temperature of 37 to 50 degrees Celsius to 40 degrees Celsius. A pH between 6.5, and 6.8, and an enzyme load of 0.5 gram per liter over a period of 3.5 hours. Regarding the kinetic parameters of this reaction, the Michaelis constant is approximately 5.2 millimolar. The maximum reaction rate is 120 micromole per minute per milligram. The turnover number is 62 per second, and the activation energy is approximately 48 kilojoule per mole. Next is the industrial value and relevance of lactase. There are two primary aspects to consider: its social value and its economic value. So for its social value, the use of lactase enables lactose intolerant individuals to enjoy dairy product without experiencing any discomfort. This is particularly significant as it addresses a major public health need that affect 80 to 95% of Malaysians. Furthermore, from an economic standpoint, the enzyme has created a premium product segment for farm fresh Malaysia. This is supported by the fact that the global lactose-free market was valued at 12.1 billion USD in 2020 and is projected to reach 80.5 billion USD by 2025, reflecting a compound annual growth rate of 8.7%. Next, in terms of product benefits, the use of lactase maintains the full nutritional quality of dairy, including essential protein, calcium, and vitamins. Furthermore, it provides a slightly sweeter taste without the need for added sugar, while also preventing lactose crystallization in frozen product. These benefits are supported by research from Kohn et al. 2020 and Ruiz Ramirez and Jimenez Flores. To provide practical evidence, we conduct a site visit to Jomcha by Farm Fresh, located in Kuala Nerus, Gong Badak. During our visit, we observed that lactose-free milk was displayed alongside regular products, showing a successful integration of this product into their bubble tea menu. Next is site visit at Jomcha by Farm Fresh, Malaysia. This photo clearly demonstrates that lactose-free milk is now being actively used and marketed directly to consumers. By showcasing the product prominently, the brand is making it easy for customers to identify and choose lactose-free option in a real-world setting.
Although the current free lactase process successfully produces lactose-free milk, it still has several industrial challenges. First, the enzyme is single use, meaning it cannot be recovered and must be replaced after every production batch, resulting in a high enzyme cost of approximately 600 ringgit to 750 per 10,000 liters of milk. In addition, the batch process requires about 3.5 hours of hydrolysis, followed by a heat activation step, which increases both processing time and energy consumption. The free enzyme is also sensitive to changes in temperature and pH, leading to reduced stability and possible batch-to-batch variation. Furthermore, the discarded enzyme contributes to industrial waste, increasing waste treatment costs and reducing overall sustainability. To overcome this limitation, we propose the use of immobilized lactase by attaching the enzyme onto cartosylbate in a packet PET reactor. Unlike the free enzyme, immobilized lactase remains inside the reactor and can be reused for 15 to 20 production cycles. This enables a continuous production process, eliminating the need for the heat inactivation step and reducing both processing time and energy consumption. In addition, the enzyme cost decreases significantly to approximately RM35 to RM50 per batch, reducing annual operating costs by more than 90% with a payback period of only 3.4 months. Overall, immobilization improves process efficiency, lowers environmental impact by reducing enzyme waste, and offers a more sustainable and cost-effective solution for farm fresh Malaysia.
Now, let me present the cost-benefit analysis of our proposed immobilization strategy. Based on Farm Fresh Malaysia's production capacity of 10,000 litres per day for 300 days per year, the annual production is 3 million litres. As shown in the table, the free enzyme system costs RM180,000 annually just for enzyme purchase. In contrast, the immobilized enzyme system reduces this to only RM10,500 because the enzyme can be reused for 15 to 20 cycles. We also save on inactivation energy, which drops from RM5,000 to RM500, and waste treatment costs, which decrease from RM8,000 to RM1,000. The total annual operating cost for the free enzyme is RM193,000, while the immobilized system costs only RM15,000. That is a cost reduction of over 90%, saving more than RM170,000 per year. The initial capital investment for the reactor is RM50,000, with annual savings of approximately RM178,000. The payback period is only about 3.4 months, making this a highly attractive investment. Beyond cost savings, immobilization offers several additional benefits. First, there is no heat inactivation step, which preserves heat-labile vitamins and reduces the risk of Maillard browning during storage. Second, the final product contains no enzyme residues because the enzyme is physically retained within the reactor, resulting in a cleaner product. Third, continuous operation in a packed bed reactor reduces processing time and increases plant throughput. Fourth, energy consumption is lower because we eliminate the heating step, supporting sustainable manufacturing. Fifth, process consistency is improved because the continuous system provides uniform hydrolysis conditions. And finally, waste generation is significantly reduced from kilograms to grams, lowering environmental impact. In conclusion, lactase enables the production of lactose-free milk, addressing the needs of 80 to 95% of Malaysians with lactose intolerance. The current free enzyme process is effective but expensive. Immobilized lactase offers 4 key improvements. First, cost reduction of over 90% with a payback period of less than 4 months. Second, reduce processing time through continuous operation. Third, improve sustainability with lower energy consumption and less waste. And fourth, better product consistency and quality. Based on these findings, we recommend that Farm Fresh Malaysia invest in pilot-scale implementation using a packed bed reactor, collaborate with established enzyme suppliers for technical support, and gradually scale up to full production. Thank you.